Okay, question 2a. And if you're struggling with anything we say here, go back and watch question 1a and question 1b. Now, what we want to do is see when are these two graphs equal to each other. So we're going to solve simultaneously. Now, I'm really reinforcing the one method, and those that have done it another method, I'm kind of helping you in the way you've done it. But let's focus on change to standard form and put the two graphs equal to each other. That's what we want to focus on here. So let's start with this one and say we've got 3x plus y equals 2, and we want to change it to standard form. I'm relying on you to hit pause and carrying on. So cool, minus 3x, so that on the left hand side we just have y. I'm going to write the minus 3x first, and this, remember, is a plus 2. So I'm going to write the plus 2 second, and that's valid. That's now in standard form. And for our other graph, we've got 6x minus y equals 25. Cool. Let's equals 25. Let's do this in the way that we have been doing it to go, well, it's minus 6x, so we're left with minus y equals minus 6x plus 25. Multiply the whole thing by minus 1. Multiply this whole thing by minus 1 so that we have positive y, because we don't want negative y. Our standard form is y equals mx plus c equals 6x plus 25. Now it's in standard form. We could also do a whole lot more. So we're not at this stage, but I could ask you what the x-intercepts are, what the y-intercepts are, what's the gradient of each function. Are they perpendicular? Are they parallel? There's just so much we can do now in standard form. So this green graph is a positive gradient because of the positive 6. So this must be, oh, how do I know that I've made a mistake with this plus 25 when I draw on top of it? What's the y-intercept of this function? Well, it's a negative. It's negative down here somewhere. So this should be negative 25. This is actually quite useful to go, oh, that's that graph. Oh, sure, must have made a mistake. And it's good to do this. So I say I keep on leaving these little bits in because it's so easy to make a little slip somewhere. And it's good to be able to see how you spot your slips. So let's check that we didn't make a slip on this other one. Minus 3x plus 2 minus 3x must be a negative gradient, which means it's going down. Plus 2 means that the y-intercept is at 0 plus 2. Cool, that's matching. And what we're trying to find in this process is, what am I? What is this point here where the two graphs are equal to each other? So let's put the two graphs equal to each other. So minus 3x plus 2. So we're asking ourselves, let's do it over here. Minus 3x plus 2. Hey, when are you, the pink line, equal to this positive green line, 6x minus 25? And now we've got an equation, and we solve. So go for it, solve. Pause, I'm just going to do it quietly in the background here. That's 3x plus 3x. That means that I've got 9x. What else do I want to do? Well, I don't want this 25, so I'm going to plus 25 plus 25. Right. So that's going to give me 27. Okay, but I don't want 9x, I want x. So I'm going to divide by 9. Divide by 9. 27 over 9 gives me 3. 9x over 9 gives me x. That's what I want. X equals 3. I've got the picture here so I can check it. Cool. How I'm going to work out what the value of y is? Substitute into either function. I'm going to substitute into the first function. Why not? Y equals minus 3 plus 2 equals minus 9 plus 2 gives me minus 7. So therefore our point, nice to just sum it up, x is 3 and y is minus 7. 3 minus 7, that's where the two graphs are equal to each other.